We now get into adding and subtracting signed fractions, which have the same rule as integers. Please, please, please leave change opposite, make two marks side by side. So in these two examples, there's actually only one leave change opposite we need to do, which is right here. So I'm going to do that in my fat red ink pen. Leave, and this is the change, and this is the opposite. Don't need to do that here because this is already plus. Okay, so now I need to think, what is the first step in dealing with fractions when we're adding or subtracting? And if you said that you need to find a common denominator, ding, 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 you're exactly right. So let's do that. Let's think about what a common denominator would be for 7 and 3. We're trying to think of a number that both 7 and 3 will go into. And when all else fails, you can always multiply them together and that will always work. So in this case, that is the first thing that will work. 7 times 3 is 21. So I'm going to have 21 as my denominator for both of these. All right, let's think about how do we get from 7 to 21? Well, I multiply by 3. So I'll multiply by 3 on the top, and 3 times 3 is 9. And the minus or the negative sign can go in front, it can go at the bottom. I personally like to put it on the top because I don't forget that it's there, or I'm not as likely to forget that it's there because I see it attached to the numerator. Okay, for the second fraction, I look and I see, well, how did I get from 3 to 21? Well, 3 times 7 is 21, so I'll do the same thing on the top. And now I have a negative 2 times a positive 7. Signs are different, so I know my answer is going to be negative, and 2 times 7 is 14. And now I have my plus sign in between, and at this point, I'm ready to take care of this. My denominator never changes, so my denominator will still say 21, and now it's a matter of what do I get when I add a negative 9 and a negative 14. The signs are the same, which means I add them and keep their sign. And when you do that, just leave it. You don't need to change it into a mixed number unless for some strange reason you want to, but I would just leave it as an improper fraction. The last thing you do need to check is to see if you can reduce it or simplify it, but I'll give you a little hint. In this case, you can't. All right, moving on to B. We need to find a common denominator. So if we look here at 4 and 8, worst case scenario, you just multiply them together and get 32, but we know there's a better number than that. And the smallest denominator that will work for both of these is actually 8, which is nice because we don't have to do a thing to this one here, at least not yet. We just leave it as negative 6 and 3/8. Coming down here, we do need to change this fraction. How do we do it? Well, we had a 4. We're going to multiply by 2 on the bottom to get that 8. So I do the same thing on the top. And 3 times 2 is 6. So I wind up with a problem that looks like this. 2 and 6/8 plus negative 6 and 3/8. Okay, this is where you kind of got a choice. You can keep these as mixed numbers. We know that we're going to need to subtract them because the signs are different. This is positive, this is negative, and when signs are different, you find their difference. Which means that if we do that, this would need to come first on the paper. We would need to subtract. We're going to have to borrow, which means we have to borrow from the whole number, change the fraction, and this is why I really prefer to change these into improper fractions. So let's go ahead and do that, and hopefully you'll see why I think this is helpful. So if I change this to an improper fraction, 2 times 8 is 16, plus 6 is 22. So that's 22/8. Now I'm going to take care of this whole thing and change it to an improper fraction and then remember the sign. So 6 times 8 is 48 plus 3 is 51/8. And then I can't forget that that's a negative. So this is what I wind up with. I wind up with a positive 22 eighths plus a negative 51 eighths. So my denominator is going to stay the same. So my denominator is 8. And now I just look and ask myself, are the signs different or the same? And since they're different, we find their difference, which means we subtract them. And the beautiful thing is here, you don't have to borrow from a whole number. You don't have to worry about changing a numerator. You just do it. And since you can leave your answer as an improper fraction, I think this is the best way to go.